Hi, I'm Bob Dodge with Artemis Gallery. Today I've got our distinguished scientist, Dr. Serge Fayul, who runs the Artemis Testing Lab. We've talked repeatedly about methods to determine if something is authentic and why we take that so seriously at Artemis Gallery. And today we're going to talk about thermoluminescence testing, or TL testing. And we brought Serge on board 6 years ago, probably, to handle that part of our business. We're one of the only galleries in the country and one of the few in the world that has made the kind of investment in the equipment and the expertise to have a TL lab on site. And we do 5 tests a day, 5 days a week, so we're constantly testing in particular pottery to make sure it's authentic. So what we're going to do today is have Serge give you kind of a quick overview of how we test things and what we look for to make sure that it's authentic or if it's a replica. So we're going to start with the testing process and how he goes through getting samples, what he does with it, and then how the results are reflected back to us. So Serge, if you want to talk about how we do the testing.
So we are using the technique called thermoluminescence, which is based on the properties of insulator materials, like clay mainly, that can store some energy over the time. We won't go into the details of the physics behind, but there are a lot of analyses that have been done to study this phenomenon. So we start with a piece. We have no idea, is it real, is it fake, and what is the edge, if it's real. So to do that, we need to take a small amount of powder from the sample. So we drill a small hole in a part of the piece. We will use this powder to do the measurement. So this powder is deposited on some small cups and will be used in the equipment at that point. So this is the TL equipment, and here are the small cups containing some amount of powder that we will analyze. So this TL equipment has a radioactive source. It's a strontium. And to show you a little bit that it's radioactive and that you need to take some precautions. So this is ambient. So you hear once in a while a beep. Once we come close to the source, so some radioactivity, and that's why we have some lead, we have some leaded plexiglass for protections. So we will now do the TL measurement itself. It consists in heating the samples, the powder, to up to 500 degrees Celsius, and we will measure the light emitted during this heating process. We will then record the amount of light emitted, so the thermoluminescence, as a function of the temperature. Here we have a sample, that's this black sample, this black piece, and it's real. So we do the following measurement. First, we measure that the orange curve in the natural state.
So that's not heated.
It's heated, but natural. So nothing is done to the sample, just we have this powder in the test. Next, and this curve will already tell us that the sample is old. Then, to be able to determine the edge, we will use some artificial radiation to irradiate the samples. So we will do 3 different doses, and that will be the green, the blue, and the black curves. 3 different doses. with this radioactive source that we have in the TL equipment. We then can plot this area, the surface area of these peaks, as a function of the equivalent dose. So the natural state, the equivalent dose is 0, and then we have our 3 radiation that will be here given in second because it's the equivalent dose. So we have this now, these 3 points. The natural one, we can calculate the regression and determine the location where this straight line will cut the x-axis. That will give us the equivalent dose of the natural sample. Based on that number, this equivalent dose, then we will be able to calculate the age. And this is also based on what we call the annual dose, which is the amount of radiation that is emitted inside the sample. Since we have radioactive elements in everywhere, including in these samples, that's the amount of radioactive element will allow us to calculate the annual dose. So what we do is, in general, we use an average number, which is more or less true for every location, but sometimes we need something more precise, and that's where we will use the XRF to be able to calculate the amount of potassium, of thorium, of uranium present in the pod. In that case, where you see that the peaks are very high, it's related to the fact that this has some thorium and some more potassium than usual.
So if you didn't measure that, what age would the equipment say this piece is?
So here in that case, we would, using the average number, we would find something like 7,000 years old. Actually, when we correct the numbers with the data from the XRF, we will find something more like 3,000.
So this particular cup is from a culture in Peru called Chavin. And this culture was prevalent between about 1000 BCE and 500 BCE. So if that dated at 7,000 years old, that wouldn't be acceptable. 3,000 years old is right on the money for what we would expect that to be. And I want to stress, I don't tell Serge what that should be. Serge comes to me and says, this dates at 3,000 years old. Does that sound about right? And I will say yes or no. Once in a while, he and I will be in disagreement on age, and that's when he may go back and look at the elemental composition. So usually we're plus or minus 10, 20%.
10 to 20%.
Yeah. So we're in agreement most of the time. Once in a while, we still disagree. But he's the scientist, and I almost always defer to him. So this is a curve of something that's right. What happens when something is not right?
So I also analyzed this piece. So again, you can see where I took the powder. Generally, we look at 2 locations on a sample. Sometimes there is some restoration, so we want to make sure that we avoid this location. For example, here you can see some restoration. But so I did one here and I did one here. So it gave us more assurance that the piece is complete, has not been restored too much.
And we do find, actually kind of frequently, that even with our best eyes, we can't tell where restoration is, and he may get one hole that's ancient, one hole or one sample that's modern, and then we'll look at the piece. We may wet it to see if we can determine areas that we think are original, and he will test again. So several of our reports, many of our reports may say ancient with restoration. So now we've got.
So now we did
curve
the analysis on this sample, and here are the curves that we obtain. The same with the orange is the natural state and the 3 irradiation doses. And as you can see, the orange one is flat. There is no peak, which means that there was no energy accumulated with time in the sample. It means that this sample has been made pretty recently. So when we say recently, it needs a few hundred years to be able to have a reasonable accuracy. Typically, something that is less than 300 to 400 years, that will be difficult to analyze, and we will put that as a recently fired clay.
So to answer a couple of questions that comes up often, how do we know something has not been restored using heat or a kiln? And that's very difficult because thermoluminescence measures the amount of light energy stored since something was heated to a very high temperature. I think it's 500 Celsius.
Yeah, 500.
So if something comes to us and has been restored and re-put into a kiln to cause that clay to dry and set, we can't tell that. That may result in a curve or no curve, as we're seeing here. So we can have no way of determining if the piece was ancient or if it's been restored. So we would just simply say the data does not show age or evidence of age. It doesn't mean it's not ancient, it just means the testing shows no evidence that it is ancient. We also include, with everything that we test, a report that shows the item, our item number, and then the results. So this is the Chinese Han Dynasty piece. Was tested, and the estimated age was 2,000 years old, plus or minus 300 years. So Han Dynasty, roughly between 200 BCE and 200 CE, so that falls right in the middle, and that's exactly what we would want to see. We often get questions, a lot of times from disgruntled dealers saying, gee, you're falsifying reports. Well, that simply is not true. I have no input into the machine, into the test results, into the samples. So Serge does all of that, and I or none of the staff have any opportunity to try and influence him on what the results are. So if you hear somebody saying, well, it's Artemis Testing Lab and they've got a conflict of interest, that simply is not true. We are interested in learning the truth. We fail our pieces as often as we fail others that are submitted to us. So when we buy a piece, I'm going to say 1 in 15 may test bad. If it's an item that's consigned, it's probably 3 in 10 that are tested as wrong. If it's an item submitted for testing, just for testing alone, it's probably 3 or 4 in 10 that fail the test. So I have no control, only Serge has access to the machine, the results, creation of reports. Authenticity or lack thereof is our number one aim. So we've invested $140,000 in this little toaster oven, paying Serge's salary. We want to know the truth, and once we know the truth, sometimes we don't like it. A lot of times I don't like it, but If something tests bad, we don't sell it. It does not go through Artemis Gallery. So if anyone has any questions at all about the methodology, how we compare with others that do this, and I'll give a quick recap. There are 3 or 4 other labs in the world that do this process. The best known, probably the most universally accepted, is Oxford Labs in England. They do a great job. Most of the museums use them, most of the auction houses, the major ones. I don't like them for one particular reason. They don't show this curve. So I can't look at that and say, gee, that makes sense. So they give a report, they'll say an age, but they won't identify the information behind it that allowed them to make that assessment. There's a lab in France, QED. Great lab, does great work. They show 2 curves. Well, you can't determine dating or aging based on 2 spots. You need more than that. So we show everything that has been tested and irradiated and the results and the methodology behind Serge coming up with these estimates of age. So all scientific, range of errors, but we take that into consideration. The most important thing that we provide is the curve. And this bottom one is the one that we specifically look at most closely. Is there a peak? Is there a bell curve of any type with this curve? If there is, we know it's ancient. If it's not, there is, you can't argue it. It's just not ancient. So again, let me reiterate, Artemis Gallery wants to know the truth. We want you to know the truth. So we sell our services to anyone that's interested in learning whether their pieces are authentic or not. The pieces have to be sent to us so that we can test it, because if we don't require that, that's when conflicts can arise. So if somebody sends in just a sample of powder, we can tell you if it's ancient or not, but we can't assign it to a specific piece. So that's why we need the piece here, or on occasion, Serge will travel to you and do the sampling at your location. We've done that all across the country. So have I missed anything?
Nope.
I think that's it for thermoluminescence testing. Thanks.
Thanks.
Cool.